Every single control panel out there, whether it's running a tiny conveyor belt or a massive robotic arm, has a hidden weak spot. But don't you worry, today we're going to lay out a clear plan to shore up those defenses. Let's jump right in. And this is really what's at stake here. Without the right protection, one tiny momentary electrical fault can snowball into total chaos. We're talking catastrophic equipment damage, thousands in downtime, and some really serious safety hazards. The good news? This is a problem we can absolutely solve. So before we can talk about the solutions, we first have to really understand the enemy. Let's break down the three main electrical threats your system is going to face. First up, we've got the overload. Now, I want you to think of this as a slow burn. It's not some big dramatic explosion. It's more of a sustained overcurrent. Maybe a motor is just working a little too hard for too long. This creates this constant heat that just slowly cooks the wire insulation over time, eventually leading to a failure down the road. Next, we have the short circuit. And this one is the big, dramatic bang. It's the complete opposite of a slow burn. It's a sudden, incredibly violent release of energy. We are talking about a current spike that's hundreds of times higher than normal, and it all happens in just a few milliseconds. This is the kind of thing that can cause an arc flash, a literal explosion of electrical energy. And finally, there's the ground fault. This one is, well, it's a little sneakier. This happens when electricity basically leaks out and goes somewhere it shouldn't, like the metal enclosure of the panel. It could be from a frayed wire or a little bit of moisture. It might not be that massive current spike, which actually makes it harder to detect, but it poses a huge risk to anyone who touches that panel. Okay, so now that we know the threats, let's look at the tools we have to fight them. Think of this as opening up the essential toolkit for any panel builder or design engineer. Each one of these has a very specific job to do. So, this table here lays out our main players. Right off the bat, you'll notice fuses have an absolutely incredible interrupt rating, which makes them perfect for places where you could have a really high fault current. Then you've got your workhorses, the big molded case circuit breakers, or MCCBs, for your main incoming power, and the smaller miniature circuit breakers, or MCBs, for all your individual circuits. The key difference, of course, is that they're reusable. And way down at the other end, for your really sensitive 24-volt DC stuff, you have electronic circuit breakers, which give you smart, precise protection. And this brings us to that age-old decision you're gonna have to make: fuses or breakers. It's really a classic trade-off. Fuses are cheap and give you amazing protection against those massive faults, but when they blow, you gotta replace them. Breakers, on the other hand, cost more up front, but you can just reset them with the flip of a switch, getting you back up and running in seconds, a lot of times without ever opening the panel door. So, we know the threats and we know the tools. How in the world do we put this all together? Well, let's move on to the blueprint, a clear, step-by-step process to make sure your design is both safe and compliant. Here's the roadmap, and it all starts with the basics. Step 1, define all your loads. You need to know exactly what you're powering, from your PLCs and drives to every single motor. Second, you have to calculate the absolute worst-case scenario, what we call the available fault current at the site. It's only after you know that in step 3 that you can even begin to size your protective devices to match those loads and keep the wiring safe. Okay, so you've picked all your components. Each one has a rating stamped right on it. But here's the million-dollar question you have to ask yourself. What is the true rating of your entire control panel once everything is wired together? The answer? Well, it just might surprise you. And here's the answer. This is absolutely critical. Your entire assembly is only as strong as its weakest link, period. So if you have this huge main breaker rated for 65,000 amps, but it's feeding a little terminal block that's only rated for 5,000 amps, guess what? Your entire panel's official rating, its short circuit current rating, or SCCR, is just 5,000 amps. That's a fundamental rule you just cannot ignore. All right, so that 6-step plan we just talked about, that's your foundation. It covers the absolute must-haves for every single panel. But, some applications have unique challenges that demand more specialized strategies. Let's take a quick look at a few of those. For instance, motors, they create this huge inrush of current when they first start up, so they need special motor protectors. If you have sensitive electronics like a PLC or a computer, you'll need surge protection devices, or SPDs, to guard against voltage spikes. For personnel safety, especially around outlets, ground fault circuit interrupters, or GFCIs, are non-negotiable. And for today's modern panels that are packed with 24-volt devices,
electronic circuit breakers give you a level of smart, precise protection that a standard breaker just can't touch.
And that brings us to our final thought for today. You see, the goal here isn't just about checking a box on a form to meet the minimum code. The real challenge, and the mark of a great designer, is to take these principles and build a system that isn't just compliant, but is truly robust, reliable, and fundamentally safe. So ask yourself, is your panel's protection just good enough, or is it truly optimized? That's the question to carry with you.